From cosmic cocoon to starlight, the universe held its breath for 400 million years in absolute darkness. No stars burned, no galaxies spiraled through space, just an endless, cold fog of hydrogen atoms drifting through the cosmic void, like ghosts waiting to be born. This wasn't just any darkness. After the recombination epoch, 378,000 years after the Big Bang, when the hot soup of particles and photons finally cooled enough to become transparent, the universe entered what astronomers call the Dark Ages. The cosmic microwave background, that ancient light we still detect today, marked the last time the entire cosmos glowed with uniform radiance. Then, silence. But deep within the darkness, invisible gravitational fingers were weaving the future. Tiny density fluctuations, like whispered secrets embedded in the fabric of space-time itself, began pulling hydrogen atoms together. Slowly, inexorably, the first structures started to condense. Not yet stars, but the ghostly scaffolding upon which galaxies would eventually hang. Then came the moment that changed everything forever. The first generation of stars ignited about a few 100 million years after the Big Bang. And suddenly the universe was no longer dark. These weren't ordinary stars. They were monsters, hundreds of times more massive than our sun, burning with such ferocious intensity that they lived fast and died spectacularly in just a few million years. When these stellar giants exploded, they didn't just die. They transformed the very chemistry of existence. For the first time in cosmic history, elements heavier than hydrogen and helium scattered across space. Carbon, oxygen, silicon, iron. The building blocks of planets, the ingredients of life. Each supernova was a cosmic alchemist, forging complex atoms in the nuclear fires of stellar death and seeding the universe with possibility. But the real revolution was just beginning. The ultraviolet radiation from these early massive stars began ionizing the neutral hydrogen that filled space, stripping electrons from atoms and creating bubbles of ionized gas that expanded outward at incredible speeds. This epoch of reionization lasted from a few 100 million to 1 billion years after the Big Bang, fundamentally restructuring the cosmic landscape. Imagine the universe as a vast, dark ocean, suddenly punctured by brilliant lighthouse beams. Each new star system created expanding spheres of ionized space, and as more stars formed, these bubbles merged and overlapped until they filled the universe entirely. The last time in cosmic history when hydrogen throughout the universe changed its state. What emerged from this cosmic metamorphosis was unrecognizable from what came before. The smooth, dark universe of the cosmic dark ages had evolved into a brilliant tapestry of stars, galaxies, and complex structures. Matter had learned to organize itself into patterns of breathtaking complexity and beauty. The universe hadn't just aged, it had grown up. Like a butterfly emerging from its chrysalis, the cosmos had transformed from a simple, uniform fog into the rich, structured, star-filled universe we inhabit today. And we are not merely observers of this evolution, we are its products, assembled from the stellar ashes of that first generation of cosmic giants, contemplating our own origins in the light of stars that never could have existed in the universe's dark beginning. The metamorphosis continues still, as new stars are born, galaxies collide and merge, and the universe writes the next chapter of its 13.8 billion year autobiography in languages of light and gravity that we're only just learning to read. Are you cool? Then like, subscribe, and share for more.